on our YouTube channel. What I wanted to do today is, first of all, congratulations with finishing Unit 3 test last class. And secondly, today we're gonna have a short, a conversational beginning of this class. Please make sure that you can use your microphones. That's crucial today. Please check if they work. There is a Zoom test available. Okay, guys. Let me share my screen now. Today we would start our new unit, Unit 4. But before that, I would like to have a conversational activity with you. And then we're gonna move on to expectations from this unit, right? So for now, please guys, demonstrate that your microphones are functioning. Let's start with Mo. How are you today, Mo? How are you doing? How's your day?
Hello?
Hello, Mo. Can you hear me?
Yeah, I can hear.
How are you? How are you today?
I'm good. How are you?
I'm doing great. As you can hear, my voice a little bit down, but I'm getting better. Um, Other than that, I'm doing great. I wanted to talk today to each one of you, asking uh, how you feel about this course so far. What do you think useful stuff that you heard in this course? Is there anything you can tell us about that, Mo?
Um,
Or in general, have your attitude towards mathematics changed or no?
yeah, a little bit. Hello?
Yes, yes. Tell us a little bit more.
Okay. What do you want to know exactly?
Like, have you seen, for an instance, that there are plenty of um, practical applications of material that we covered, especially in rational functions. It's like a very broad chapter that is, as for me, used in many spheres of life. Business, economics, physics, etc. Have you seen any relations between this and other courses, for an instance, between physics? Have you taken physics courses?
Yeah, like yeah, a long time ago actually.
Mm-hmm.
It was like 2, 3 years ago.
Yeah, so tell us a little bit. Wherever
Um,
you feel. It's not a graded activity.
no, I just like,
We're
I
just getting to know each other a little bit more in this
yeah,
course, so we can get comfortable because upcoming courses will,
n-
upcoming units will require a bit more of our mutual communication.
no, I understand it. No, the thing is, I just like finished work, like as you know, like 'cause I was working last night. I'm
Mm-hmm.
and I'm kind of like tired,
I
and
understand.
yeah. So, yeah, the course is actually pretty good, like in my opinion. Like I've been learning a lot of things, and yeah, like
Mm-hmm.
I think I joined late, and I missed
Okay.
out on a
No
lot of
worries.
things,
No
and I'm
worries,
just trying
Mo.
to catch up.
We
Yeah.
will catch up all together. You can
Okay.
always request a help,
Right.
and you'll be great. Just get into stream of studying, and you'll be good. Okay.
Okay, sounds good. Thank you.
Okay. Let's move on to Safa. Safa, tell us about how you feel about mathematics course in general. As for me, it seems like you kind of like it. Am I right?
Yeah, I think it also helped me develop strong mathematical skills. I also find myself like I'm able to problem solve. I have problem solving abilities and like a deeper understanding of like algebraic concepts. Like I have a higher level of learning now from math. So yeah, I'm very proud of myself for that.
Yeah, I can tell from your solutions that you provide that you quite have your own approach to solving problems. And that's really great that you opened that skill in yourself.
Mhm.
Would you say that you feel like mathematics is going to be part of your future career?
Yeah, I'm gonna go into nursing, so that's why I'm taking this course.
Okay, great, Safa. Thank you for your feedback. Hala, how about you? How are you doing today?
Good, and you?
Good, good. Thanks for asking. So, would you mind telling us a little bit about how you feel so far into this course, mathematics, advanced functions? Maybe there is something you would like to do differently in our following units.
Not at all. This course has been an amazing course. I like the practice questions that you keep giving us and the constant feedback that you also give us. It's it's such a help.
Mm-hmm. Thank you. I appreciate it, Hala. I really trying to do my best in order for you to feel comfortable in this course and for you to gain really useful knowledges because um mathematics is a very wide subject, right? And when you start learning it, it feels like it's unbearable mountain that you could never fully cover, right? But in reality, it's like learning how to walk or how to write. Once you get to the basics, the next and the following steps are getting easier and easier. And for me, mathematics is just all about constant practice. What, Hala, what would you say about last test? How you feel? Was it too easy or was it too hard or it was right enough?
Um, Matter of test depends on each student and how much they practice. I think I practiced good enough and so the test wasn't that hard for me, but some other student might say otherwise. It just depends on the person.
Okay, great. Thank you guys. Thank you for your feedback. Ahmad joined us recently. Ahmad, do you have a opportunity to turn on your mic to share your feedback about this course? Okay, I believe Ahmad having some issues. So I suggest we move on to our new unit, radian measures. Later, Ahmad, if you fix your microphone issues, you could join us. So this unit number 4, it doesn't says on the screen. I'm so sorry for that, but it's going to be related to trigonometric functions. And as for me, for my studies, this was one of the most complicated units to cover because it involves geometry as well as mathematics. And for some students, it's really hard to bring those two pieces together. But I, I tell you that there is nothing to be afraid of because, as always, mathematics is based on rational approach on analyzing and structurizing your solution. And trigonometric functions are no different in this aspect. So I would like to bring you through overall expectations from this unit. Overall expectations from you are to be familiar with basic trigonometric functions as such as sine, cosine, tangent, but about that we're going to talk a little bit later. And secondly, to be able to solve equations involving those trigonometric functions. In talking about specific expectations, we're going to solve as well as equations as well as inequalities with trigonometric functions. And also, um, um, talking about trigonometric functions, it is important to understand that you're expected to make connection between radial measurements and converting them into degrees, because that's part of how we evaluate trigonometric function, okay? And why don't we start with our first slide, in which we define what radian is, right? Does anybody remembers maybe from past courses or physics or geometry what radian is? Anybody? I believe you should know this. This is not something super uh, super specific. Okay, then I'm gonna call somebody out. Safa, would you mind trying explaining us what radian is, and then I'll give my explanation. Okay, let's do it the following way. I'll do it first, and then you'll try to explain it in your own words. So As you could see, radians is one of the measuring techniques for angles, right? It initially comes from a ratio of the length of a radius of a circle to its circumference. I believe you heard about number pi, right? This number stands for 3.14 hundredths as a number. It has no measure. That's what you thought before, but basically pi stands for 3.14 radians, and that's the ratio of a radius to the circumference. If you divide the circumference of any circle by its radius, you would get 3.14 or pi ratio. So basically, how do we use it to measuring angle? Basically, we set angle in the correspondence to the arc of length A. As you can see on the screen right here, I'm gonna highlight it. Here's our arc with length A, right? And it's separated by angle theta, right? And this arc has a certain length, basically, and we could set this length in the correspondence to the angle. Okay, let me try to explain it one more time, because this is very important thing to clarify. Basically, sorry. The way I would explain it, okay, let's say you have a full circle. Full circle would contain pi radians. It's a full circle. Pi, as you know, we usually round it up to 3.14. Actually, pi is an incredibly long number after the dot, but for convenience, we use only first 3 digits in it. That's how many radians are in one circle. And now let's say we have a radius of this circle, and let's say we split this circle in 3 pieces, like a weird pizza. Okay, now each one of these segments is going to have equal number of radians, or pi divided by 3. Pi divided by 3 would be equal 3.14 divided by 3, and we could say that it's roughly would be 1.04, and then it's gonna be like 6, etc., and so on. But this would be numbers of radians in 1/3 of a circle, right? And I believe you should know that how many degrees are in circle. It's 360 degrees. Does everybody agree with me on that? Full circle is 360 degrees. I believe degrees are more convenient for you to talk well, when talking about circles or angles. Now, you know that 360 degrees is a whole circle, right? And we also know that pi is a whole circle. So we literally could say that 360 degrees is equivalent to pi, to letter pi, or to pi radians. Pi radians. Oh, wait. Oh, I made a mistake. Actually, it's full circle is not only pi, it's 2 pi. I'm so sorry. Pi is a half. It's 180 degrees, and 2 pi 360 degrees. I'm so sorry for misleading you. 2 pi is 360 degrees. 2 pi, this is very important. So 2 pi is 2 times 3.14. This is how many radians in full circle. So times 2 here, 2 for 1/3 of a circle, 2 pi divided by 3. Here times 2, and here times 2 as well. Okay? Just keep that in mind, that 360 degrees is equivalent to 2 pi, or 2 pi radians, because pi is measured in radians. What it says here, that radian, another way of measuring angles, and it is the measure of an angle subtended at the center of a circle by an arc of length a divided by radius r. Is there any questions about this slide? May I move on? If you have any questions, please ask them now. Okay, great. I suggest we move on. Here you can see how we identify this angle theta. For an instance, if the arc is given and the radius of a circle is known, right? First of all, we know initial relationship between the arc, the radius, and the angle that is defined by this arc. And but it is important to remember this angle is measured in radians, not degrees. This relationship between arc, radius, and angle is true only if we measure angle in radians. If you have angle given in degrees, you have to convert it first to radians in order to calculate this properly. Basically, as what I told you before, that radians is the ratio, right, of the radius to the arc length. That's what we see here. Basically, if we play with this relationship, with this equality, what we can see, that length of an arc divided by radius, right? I just divide left and right hand side by radius. You see? Gives me my angle theta in radians. So what conclusion I can make here? That my angle in radians is the ratio of an arc to the radius of a circle. Does it make sense? It's like the easiest way to understand what radians are. Mo, what would you say? Is it clear about radians? Okay, Mo is resting. Safa, what would you say? Is it a good explanation of what radians are?
I think so, yeah.
Okay, great. If nobody else have questions, we'll move on. Guys, and now, please, if you have ability, I would like to ask Hala, can you use annotation tool? Based on what I just told you, do you think you could solve example 1 now? Let's look at it together first. Circle with a radius of 2 centimeters. Okay. Or maybe I can do it in a nicer way. Where is it? Yeah. Circle. Right? And it has a radius of 2 centimeters, right? 2 centimeters. This is our radius, R. Has an angle theta subtended by an arc 5 centimeters in length. So let's let me use like red pen. And let's say there is a 5 centimeter arc that is separated like this, right? It's 5 centimeters in length. And we have angle theta here. This is our angle theta. Remember how we denote arc? A. Letter A is the arc length. Find the angle theta. Hala, could you do that for me, please? Was your reason, was your explanation verbal? You can use annotation tool just as I do it. It's on your toolbar on top of your screen or on the bottom and says annotate. Could you do that, please, Hala? If no, I will ask somebody else. Or Ahmad, maybe you would like to try. Ahmad, Ahmad? Mo, would you like to try this one? This is an easy exercise. Hala, can you do it?
Do you figure it out by like putting the 5 over the 2?
So go ahead and write it on the board so you can show us your solution. And just keep in mind that angle theta in radians is the ratio between the arc lengths and the radius of the circle.
So would you like use that formula? Which
Yeah,
is like
absolutely
you
right.
put the 5 over the 2, which would give you 2.5.
Great, absolutely right. So your answer is that theta equals to 2.5 radians. Is that correct?
Yeah.
It seems like a right answer to me, because remember, basically when we talk about angle in radians is how many radiuses can we fit into this arc length. That's how I think about it. How many radiuses can you fit in there? Because into the whole circle we can fit 2 pi radiuses. 2 pi radiuses, okay? Is that clear?
Yes.
Great. By the way, 2 pi is like 6.28 and so on. This is part of a class where we make connection between radians and degrees. So as I said before, in degrees, 1 revolution is how much? 360. That's easy question. I wouldn't bother you turning on your microphones on this. And in radians, 1 revolution is 2 pi. 2 pi. Radians to degrees. How to convert them? This is very, very interesting question. It's a really important one. Let's think about it together. So we want to convert some arbitrary angle from radians to degrees, right? I want you to think about it for a minute. How would you do that? Knowing that basically the relationship between degrees and p and radians is such that 360 degrees equals to 2 pi and pi equals to 3.14. Please think about how would you convert one to another, and I'll get back to you in a few minutes. Plus it's 10:45, so I suggest we have 10-minute break now, and after break we will talk about how to convert radians to degrees. Okay, guys, I'm back. Any idea? Anybody came up with an idea how to convert radians to degrees? And you still have 2 more minutes of your break. If you want, we could wait that. Or if you're ready, we can continue right away. Okay, guys, now officially break is over. And let's continue discussing how to convert radians to degrees. First of all, basically, let's find out how many degrees are in 1 radian. We know that 360 degrees is equivalent to 2 times pi. And if we divide 360 degrees by 2 pi, we basically gonna figure out how many radians fits, or how many degrees fits in 1 radian, right? First, let's simplify by 2. We're gonna get 180. Here it is, pi equivalent to 180 degrees. And now let's divide 180 . 1, 4. Constant pi was defined by ancient engineers when they were studying circles and wheels. So you should just remember that pi equals to 3.14, and 180 divided by 3.14 gives me 57.3248, but let's round it up to the nearest hundreds as pi itself. So it's going to be 57.32. That's how many degrees are in 1 radian, right? So now, basically, for example, if you're given with an angle of, let's say, pi over 2 in radians, Radians to degrees, pi over 2. Pi over 2. You have to, basically, this is number of radians that you're giving with. So you have to multiply pi over 2 by not this degrees, right? But why would you use 57.32 as your multiplier? You should use 180 divided by pi, right? Because 180 divided by pi is equivalent to 57.32 degrees. Basically, these are the radians, number of radians we have, and this is how many degrees fits in 1 radian. Result of this multiplication would be pi is getting simplified, 2 and 180 simplified. As a result, you get 90 degrees. Answer it, pi over 2 equals 90 degrees. And it's logical because 2 pi equals 360 degrees, pi equals 180 degrees, and pi divided by 2 equals 90 degrees. Is that correct? Guys, does everybody agrees with me on this? Muhammad, welcome to the class. Tell me, do you understand now how to convert radians to degrees? Okay, silence. Mohammed, well, thanks for joining the class. Can you tell that you understand now how to convert radians to degrees? While we're waiting for your answer, I'll move on to degrees to radians. While before we discovered how many degrees fits in 1 radian, to convert degrees to radians, we should know how many radians fits in 1 degree. So what we're doing is we have to do the opposite thing. We have to divide pi by 180, right? And that would give us how many degrees are in 1 radian. You could do it easily with your calculator. 3.14 divided by 180. Let me see, how much is that? 3.14 divided by 180 is 0 equals to 0.017 in period. So let's say it's 0.017 to 3 digits after this dot. Or if you round it up to 2, it would be 0.02. So basically, 1 degree fits 2/100ths of a radian, right? Now, to convert degrees to radian, let's say you have 90 degrees, right? In order to convert this to radians, you have to multiply it by pi over 180. And it would give you, after simplifying it, this and that, it will give you pi over 2. And as we can see from converting radians to degrees, pi over 2 equals to 90 degrees, and now we show that 90 degrees equals to pi over 2. Mohammed, yeah, submit your assignments, but I don't understand what you're asking about midterm. Midterm what? But for the rest of you guys, is it clear how to convert radians to degrees and vice versa? Now, wherever you have a angle in degrees, you know how to express it in radians. And whenever you have angle in radians, you know how to express it in degrees. Mohammed, I believe your midterm card has been filled out. You just need to, and it's been sent to school principal already. So I believe you should have it. Please double check it. So it's been sent to school administration. I'll double check it on my side too. Thanks for not letting me know. Okay, guys. And Mohammed, there is no need actually for you to do home assignments related to Unit 3 test if you have submitted the unit test itself already, because home assignments are made as part of your preparation for test, and that's what ensures your good result in test. Okay. Okay, guys. Let's move on. If no questions about this part. Convert degrees to radians. This I would like you to ask to do. Now, each one of you would get two questions assigned. So, Hala, degrees equals radians divided. As I said, let's move back. Look, to convert, if let's say if you know radians are known. If you want radians be converted to degrees, operation that you're doing here is multiplying by 180 over pi. I won't write it because it takes so much time. But basically what you do, look here. Let's say you're given with radians. You have to multiply it by 180 over pi. Radians are on the bottom. Degrees on top. If you know degrees and you want to convert them to radians on top, degrees on bottom. That's how you could memorize it. Because I don't really understand what you are trying to write there. No. Oh, I see. So you say degrees of an angle equals radians of this angle divided by pi times 180 degrees. And for radians, it's degrees times pi divided. Yeah, that's the same thing that is written on the screen, but in different order. You recombine them. You divide the radians by pi and multiply by degrees. And for radians, you divide the degrees by degrees 180 and multiply by pi. Yeah, it's correct formula, but if you look, what you're saying is that you just you're recombining them. First, you divide by pi. Here, for example, radians to degrees. You divide by pi first, and then you multiply by 180. So basically what you're saying is that you don't have it here, but instead you have it here, right? And then you multiply by 180. It's the same thing, right? And on the other hand, what you're saying here is that you're not multiplying by pi over 180, is that you're dividing by 180 first, and then multiplying by pi. It's the same thing. Doesn't make any difference. Depends on how is it easier for you to memorize it. Because as for me, it is much easier to memorize it when you know, for example, you're giving with angle in radians, you need to turn it to degrees, you multiply by 180 divided by pi. You're given with angle in degrees, you need to convert it to radians, you multiply it by pi divided by 180, basically flipped over. It's not, listen, it's not that you could get a right answer by accident, but it doesn't mean your solution is right, okay? In this case that you offered, you're just doing the same operations, but in different order. It doesn't mean your solution is wrong because of it. For example, if you did some random operations like multiply by 3, divide by 3, then multiply by 5, substitute 4, then plus 4 times 5, that these operations have nothing to do about converting radians to degrees. It's just random operations. Then I would say it's wrong solution. But what you're saying here is that you're performing same operations but in different order. Is it clear, Hala? Same operations, different order, what you're saying is. Okay. Thank you for clarifying that. I would like to send your message to the group chat. Do you mind? Maybe other students would love to remember it this way. So please check this message. This is how Hala memorizes how to convert. Basically, first line is radians to degrees. Second line is degrees to radians. Thank you for that. Okay, so now let's implement what you just learned. One more time, what Hala wrote. First line is radians to degrees, and second line is degrees to radians, how to convert them. Now I would like to ask, so red color would be for Hala, this and this. First one converted from degrees to radians, another one convert radians to degrees. Blue color would be for Safa. Then green color would be for Muhammad. Muhammad. This. And I'll write you your example, convert radians to degrees. Let's say it would be pi over 3. This is for Muhammad. Muhammad. Who else? I don't think Ahmad or Mo will participate. Mo, Muhammad, would you mind trying participating? Muhammad, yeah, please use annotation tools right on the screen, please. Oh, one more thing, guys. I have to clarify it. Safa, stop for a second. When we describe angle in radians, you could keep pi as it is. It's not all, you're not always obliged to give an exact number with the fraction or with decimal points. So for an instance, instead of writing 3.14 when converting to when converting degrees to radians or radians to degrees, try to keep 3.14 as pi until the very end. Until the very end. And in the end, you can substitute 3.14 for pi. But try keeping 3.14 as pi until the very end. For example, here on the right-hand side, you can see it's 4 pi over 3. That's expression in radians, and you don't have any decimal points, right? You just have nice little fraction, which is more convenient. Okay, Hala? Hala, recall that in order to convert degrees to radians, what you should do is to multiply the number of degrees by pi over 180. Or as suggested, yeah, you could first multiply by pi and then divide by 180. Yeah, Safa. Yeah, great. And also I would adjust. So let me see, Hala. So what you're not supposed to express it in decimal points, because if you look on the right hand side, you can see that radians here, they expressed using letter pi. So you have 30 times pi over 180. What I would like you to do is to, first of all, simplify 30 and 180, right? And keep pi on top. So what you would get is pi over 180 divided by 30. How much is it? It's gonna be 6. And this would be your answer in radians, pi over 6 radians. This is how much is 30-degree angle. Do you see it now, Hala? You see, because when you have decimal points, if you Google number pi to give an exact number, for example, in test, they could ask you to give a number of radians in decimals. Okay, you do that, but they would state until what decimal point you should round it up. But in general, it's convenient to keep pi in your expression because it's more obvious that way. What angle are we talking about? And with time, you're gonna get used to it. For Safa, I would correct your mistake here because what you were supposed to do is to, here, you would have to multiply 150 here. I would like you to multiply 150 by pi over 180. First of all, we can cross out this 0, right? Now we have 15 divided by 18. What else can we simplify here? We can simplify 3, no? Yes. So if we divide by 3, it's going to be 5. And this divided by 3 would give us 6. So my answer would be 5 pi over 6. 5 pi over 6 equivalent to 150 degrees. Do you agree with me, Safa?
Yeah.
For me, this way is more convenient than trying to express it in decimal places. Okay, now Hala and Safa move on to converting radians to degrees.
That's true.
Yeah, Hala, no need for radians to degrees. No, with degrees, of course you're gonna get an exact number. Just look at it, because when you multiply it by 180 divided by pi, your pi is going to simplify itself, right? And you're gonna left behind with normal numbers. So you can get an exact answer when converting radians to degrees, because pi simplifies itself. You see? For Muhammad, nice try, Muhammad, but I don't understand why you try to express the answer in decimals. And this is not, this doesn't seem right to me. So you mixed it up a little bit. You divided pi by 45 degrees for some reason. But what you were supposed to do is 45 degrees times pi over 180. This is how you convert degrees to radians. Pi over 180. Now you have to do what? You have to simplify 45 and 180 in this expression. 180 divided by 45 would give us how much? Would give us 4, right? So, and 45 turns into 1. So my answer would be pi over 4. So 45 degrees is equivalent to pi over 4. You see, Mohammed? And then if you want to express in decimal points, no problem. You just substitute 3.14 for pi divided by 4, but it's unnecessary work. It's just like, I don't know. It's just like, I wouldn't even find an example. It's just something that is unnecessary because pi is known constant value. Let's see what Hala did here. 180 divided by pi times 4 pi over 3 pi crossing out. Great. Then 180 times 4 divided by 3. 180 times 4 is 720, right? Or divided by 3. 720 divided by 3 is 240. Absolutely right. Wait, is it? Well, let me think. 2, 4. Yeah, 240 degrees. Absolutely right, Hala. Good job. Good job. Let's see. Mohammed, meanwhile, try to convert pi over 3 to degrees. You see, now you had pi over 4 equals to 45 degrees. Safa. 180 over pi times 7 pi over 4 equals 315. How did you get 315? 315 degrees. I don't get it.
I multiplied them.
180 times 7?
180 over pi, and then times 7 pi over 4.
So what I would suggest here is that you simplify by crossing out pi, because here you divide by pi and here you multiply by pi, right?
Yeah.
So as a result, it's just gonna get simplified. Next, we can simplify 180 and 4. 180 divided by 4 would be 45, isn't it? 180 divided by 4 would be 45.
So when you cross out, that means that we don't put it in the calculator?
Yeah, because I cross it out because I simplified it, right? Because instead of dividing and then multiplying by pi, I simply skip that operation because I know, if you multiply by 2 and divide by 2, how would your number change? It wouldn't change, right? So, and as well, if I cross out, it doesn't mean I don't put it in calculator. For example, here, if I cross it out, pi and pi, I cross it out, they just like turn into 1, because basically it's pi over pi, right? Pi over pi, which equals to 1. I don't put it into my calculator because multiplying by 1 doesn't make a difference. Then 180 divided by 4, I cross it out. Basically, I divide 180 by 4 and 4 by 4. So 4 divided by 4 gives me 1. Right? Here's I'm gonna get left behind with 1, and 180 divided by 4 gives me 45. Right? Basically, now only thing that is left behind for me is 45 times 7. Right? This is the thing I didn't simplify it yet. 45 times 7. How much is that? Well, Safa, please, could you calculate this expression again while I check? Oh, sorry?
45 times 7?
Yeah.
It's 315.
How much?
315, 315.
Oh, so you remember, you did it right the first time. I was just double checking it my way. So but you just put all the numbers into your calculator, right? And in my approach, I just get rid of unnecessary operations to speed up my calculations.
Okay.
But you did it right the first time. Good job, Safa.
Thank you.
Muhammad, let's see what you did. You see, Muhammad also, he wrote 180 over pi times pi over 3, and he just crossed out pi. Easy. No need to put it in the calculator. Oh, no, why would you divide by 4, Safa? Your final answer is 315. So 7 pi over 4 equals 315 degrees. Yeah. And for Muhammad, good job crossing out pi. You don't need to do it so intensively. Just one line would work for you for future solutions. And 180 divided by 3 gives truly 60 degrees. Good job. Pi over 3 equals 60 degrees. And let me show you one more time the way I do it on this example, 270 degrees. How do I convert it? If nobody against, you have this copied down, guys. Now you have an idea how to convert degrees to radians. This is very important aspect of trigonometry, I'm telling you, because you're gonna convert frequently. Can I clear the desk now? Okay. Thank you, guys. Good job. Oh, let me actually save this. Okay. Now let's clear all the drawing. And 270 radians. How would I do it? I would say 270 degrees times 5 over 180. Okay, now I look. How can I simplify it? First of all, 270 and 180, it's like 27 times 10, right? This is how I simplify in my head. And 180 is 18 times 10, right? So I can simplify 10 right away. Okay, great. Now 27 and 18. How can I simplify that? What common factor do they have? 27 and 18. I would say 9 isn't it? 27 is 9 times 3, and 18 is 9 times 2. Is that correct? The common factor would be 9. So 18 is 9 times 2, and 27 is 9 times 3. So now I can cross out 9 because I have it here and there in numerator and denominator. And what I'm left behind is 3 and 2. So 3 pi over 2 is equivalent to 270 degrees. Is it clear, guys, how I do it now? What would you say? Isn't my approach convenient? I don't even need to use my calculator. Try using it next time. Maybe you can save yourself some time. Plus, what if one day you forget your calculator for a test? How would you do it? Great. I suggest we move on. How much time do we have? Plenty of time. Let's solve this nice little problem here. Ferris wheel with diameter 84 meters. Let me sketch that. Everybody knows what Ferris wheel is, right? Something that looks like that. It has support, right? 2 legs of support. And people having fun on it. We know that it has a diameter of 84 meters. Remember, diameter is is a line that joins 2 points on the circle, and it passes through middle of a circle. That's part of geometry classes. This diameter, call it D, diameter equals to 84 meters. 84 meters. And Ferry wheel completes 1 revolution every 12 minutes. So T, big T, period, right? In which it completes 1 full revolution is 12 minutes. Find the angular velocity, omega, in radians per second. Take a moment to think about it. How would you do that? Okay, any ideas, guys? This is a really core exercise. I would like, Safa, would you like to test your strengths in problem-solving techniques? Because this, you can come to an understanding of how to solve it while solving it. Please try it.
Yeah, I attempted to do A, but I could be wrong.
No, don't be afraid. Just please write your solution and we'll discuss it together.
Yeah.
Okay, guys, sorry, I'm back. I had to leave you for a second. Okay, Hala, can you explain? Oh, Safa, sorry. Can you explain your solution?
So the question says a Ferris wheel with diameter 84 meters
Okay.
completes 1 revolution every 12 minutes. So it asks per second. So I just put the meters over the minutes, which equals seconds, but I don't know if I'm right.
Okay, I got it. So, first of all, one way to check your answer is to check the basically that you receive at the very end, right? What you're having here, you were asked to find angular velocity in radians per second. But if you look into measures that you have here, 84 is what? Is meters, right? 84 is meters. And here in denominator, 12 minutes, right? These are minutes. So basically, as a result of this operation, 84 divided by 12, you're gonna get meters by per minutes. Isn't that correct? So whatever measure that gives us, it's definitely not radians per second. So what I suggest doing here, first let's figure out how do we understand angular velocity, right? Basically, angular velocity, if let's say this is our horizontal line, and this is certain angle omega, right? Angular velocity would be how fast, for example, this point on a circle moves here. And angular velocity would be the rate of change of this angle. Remember, at the beginning of this course, we had the rate of change. And I don't know, Hala, if that would be right. I don't know what you did, okay? You just need to write your solution. Let me just explain angular velocity, and then you can write your solution. Sorry, guys. So angular velocity is basically rate of change of an angle between one position to another. So we know that Ferry wheel completes 1 revolution every 12 minutes. So it takes 12 minutes for the Ferry wheel to make one full rotation. So basically, in 12 minutes, we make one full rotation. So basically coming to where we started from. So in 12 minutes, we're passing 2 pi radians, right? 360 degrees. Basically, what we have here, and what is speed, right? It's a distance divided by time. Is that correct? Distance divided by time. But we want angular velocity. Angular velocity would be angle divided by time. If we know that we pass 360 degrees in 12 minutes, that would be our angular velocity. But it would be degrees per minute, right? Degrees per minute. But we wanted radians per second. So we need to convert 360 to radians. 360 is how many radians? 2 pi radians. No need to give a decimal points. It's 2 pi. And what about 12 minutes? How many seconds is that? 12 minutes. So there are 60 seconds in 1 minute. If we have 12 minutes, 12 minutes times 60, it would be 720 seconds. Isn't that correct? Do you agree with me? 720 seconds. So 12 minutes equals 720 seconds. Now, if we want to know our angular velocity in radians or theta, omega, sorry. So omega equals 360 divided by 12, or it also equals 2 pi divided by 720. Also, we could simplify 2 and 720. 720 divided by 2 would give us 360, right? So pi over 360. This is our angular velocity. Do you agree with me, guys? This is our angular velocity. And now, Safa, the way I check if my answer could be correct, first of all, I check the measurements in which, what measurements am I making here? P is radians, right? P is radians. And on the bottom, 360, what is that? Those are seconds, right? Those are seconds. Does everybody agrees with me on this one? That I found angular velocity in radians per second. Thank you, Safa, for showing your approach, but it helped us to see how to check your answer in order to understand whether it could be right or not. But your reasoning was absolutely right. You divided the distance by time, but you had to check whether the distance is angle or length, and whether that time is minutes or seconds. Okay? Hala, can you show us your solution now? You said that you use a physical approach. And please, can you comment it?
Basically, it was the same thing as what you just did, just I looked at it as a complete physics question, not a math one.
Okay, how different is it?
Just used velocity, like for angular velocity, it's v equal delta d over delta t, which is delta d can be angular displacement, which could be in radians, and t is the time taken. Switching it up using the 360 over 12, getting 2 pi divide 12 minutes, and then within the same equation, I did 2 pi over 12 times 60 seconds, which can change the 12 into seconds.
Great. So you basically did the same thing.
Yeah.
And but you're absolutely right. The only thing differently you did is that you explain the angular velocity in more physical way. I explain it in like a mathematician, how I understand velocity. But in physics class, you would say that angular velocity equals delta theta, which is an angle, right? Theta over delta t. Is that correct?
Yeah.
Change in angle with respect to change in time. This omega is angular velocity, and this angle is theta, right? But what about question B? How far has the rider traveled 5 minutes into the ride? Safa, how would you, oh, Hala, sorry. How would you solve this one?
Just use distance equal radius times angular displacement.
Distance equals time times,
Which is in this situation would be theta times the W, which is the V, times T.
so you want to say omega times time equals equals displacement, right? But how do you understand this question? How far has a rider traveled? Considering that he's traveling on a circle, does it mean how far in line from initial point he traveled, or how far by the circumference? Like, are we talking about his path or his displacement?
I took it as the distance because if it was displacement, it would still be 0 all the way around because he's ending up in the same place.
No, but he's traveling for 5 minutes, not for 12 minutes. 12 minutes it would be 0, but in 5 minutes it's not. As I understand it, is how far has a rider traveled 5 minutes into the ride? I mean, how far in line? If we join starting point of his travel and the ending point of his travel, that would be how far. Or are we treating how far as a length of the circumference? Because if we would like to know the straight line, it turns into more complicated problem. If we talk about the length of an arc that he traveled, right, it's going to be a little less more complicated. So the way I would do it, I would treat this question as what is the length of an arc that the passenger traveled in 5 minutes? Because this is part of our trigonometric problems. That's what we covered in this class, actually arc lengths, right? Let's quickly answer this question and call it a day. So we know angular velocity, W, or omega. Basically, and knowing the time, we could tell how many radians is going to pass by multiplying angular velocity by 5 minutes by time, but we know angular velocity in seconds. So let's convert 5 minutes to seconds as well. So we would have pi over 360 times 5 minutes converted to seconds would be 300, right? 300 seconds. Now we can simplify 10. Now 1336. I would divided by 3, because 30 is 3 times 10. And 36 is 3 times 12, right? So we can cross E. Also 10 and 12, we can simply factor by 2. So it's going to be 6 and 5. So 5 pi over 6. This is the angle that he's going to travel in 5 minutes. It's less than 180 degrees of a circle, so less than a halfway of a circle, right? But look, we know we're giving this diameter of a circle for some reason, knowing that diameter is equivalent to 2 radiuses. So we can know the radius of a circle. Radius would be 42. So if we know the diameter is 84, then radius equals to 42, right? 42 meters. And let's remember the very first formula from today. How do we find the length of an arc? Length of an arc is A, remember? So we know that angle, so here is theta, the angle that person travels in 5 minutes, equals 5 pi over 6. And we remember that theta, right, equals to A divided by R. Is that correct? Does everybody agrees? Considering that, we could say that A equals theta times radius, because we multiply left and right hand side by radius. And we know we need to find the length of this arc, A. A equals theta. Theta is 5 pi over 6. Times radius, times 42. Now, 42 divided by 6, it's gonna be 42 divided by 6. It's 7, right? It's gonna be 7. Does everybody agrees? This is 7. 6 simplified. So 5